All right, in this example, we're going to apply the law of detachment to draw real world and mathematical conclusions. Well, that sounds like fun. Okay, so example two, apply the law of detachment to draw, oh yeah, okay, that's what we just said. So it would be helpful to know what the law of detachment is. So here's some more vocab for you. A law of logic, so law of detachment is a law of logic that states if a conditional statement and its hypothesis are true, then the conclusion is also true. Go ahead and pause and write that in. Okay, so what that looks like in our symbols that we've been using, if P then Q, so there's your conditional, and the hypothesis P are true, then the conclusion Q is true. That's the law of detachment in symbols. So let's make sense of the law of detachment with a real world and mathematical example. So assume that the set of given information is true. Here we have a conditional. It says, if Alicia scores 85 or greater on her test, she will earn an A as her final grade. So that's the conditional. I'll go ahead and write above that. There's your if P, then Q. And it tells us to assume the set of given information are true. So if your conditional is true, we've got that, and the hypothesis. So the next thing they told us was that Alicia scores 89 on her test. Because 89 is greater than 85, which is in the hypothesis over here, if she scores 85 or greater, well, she scored greater, her hypothesis is true. So if your conditional is true and the hypothesis is true, you can conclude that the conclusion is true. So what can you logically conclude? Here is our conclusion right here. She will earn an A as her final grade. So we are concluding Alicia will earn an A as her final grade. So again, law of detachment. If the conditional and the hypothesis are true, then the conclusion is also true.